Okay, this is going to be the final video of the 3 videos on roots of polynomials, and I want to just look at a couple of problems where it looks like we can't use our quick substitutions method, but if we find some inventive way in, we can find a substitution that will save us an awful lot of time. This question that I've got up now is actually a question from an OCR 2022 A-level paper, which was expected to be done with Rietta's relations, but if you try it out with Rietta's relations, it's really, really difficult. There's a lot of algebra involved, and particularly under exam conditions, very hard to do it in the time you should be given to a 6-mark question. So I want to show you a cheeky other way around it, which will save you a lot of time and save you a lot of hard work in the long run. So it looks like we can do a substitution because we're getting a mix of alphas and betas, or betas and gammas in each of the roots. So there's no automatic substitution to make here. The clever idea that we can use here is we can note that alpha plus beta is the same as alpha plus beta plus gamma subtract gamma. Why is that a clever thing to notice? Well, alpha plus beta plus gamma is a value we know. If we go back to our Rietta's relations, the sum of the roots is just equal to that negative b over a. So given a is 4 and b is 6, the sum of the roots is just going to be negative 6 over 4 or negative 3 over 2. So this is equal to negative 3 over 2 subtract gamma. Similarly, this one, by just adding alpha and subtracting alpha, so saying this is the same as alpha plus beta plus gamma minus alpha, is just negative 3 over 2 subtract alpha. And this final one is just going to be negative 3 over 2 subtract beta. So now we're at a situation where actually this looks exactly like the sort of substitution questions that you should have done before. So all we need to do in this question now is to say let w equal negative 3 over 2 minus x, because we taken our x values and we want our new roots to be negative 3 over 2, subtract that, rearrange to get x and sub that in. In this case, if we actually add x and subtract w, we end up with almost exactly the same thing. We end up with x is negative 3 over 2 subtract w, and all you'd want to do is, in this case, is go back to that original equation and replace that x in terms of w. So you're going to get 4 brackets, negative 3 over 2 minus w all cubed, plus 6 negative 3 over 2 minus w squared, and then you're going to get negative 3 brackets, negative 3 over 2 minus w, and plus 9 equals 0. You can't leave your answer as in this form. You want to get it just with w squared, w cubed, w squared, and so on. But this is just going to turn into an expansion question at this point. I'm not going to go through the whole expansion. I'm just going to mention how I do the first step, because you could go straight for binomial expansion, and that might be fine. My recommendation here, I think, would actually to be rewrite this as negative 3 minus 2w in brackets all over 2 all cubed, and this just, I'd need the plus there if I was to do that. And there you're probably making your life a little bit easier with your expansion rather than having to worry about all your fractions. So I'd do that as the first step, but that's personal preference. You can go either way. The important thing is not jumping straight in with Rietta's relations and seeing if we can make the substitution. It's worth playing about and trying it with Rietta's relations, but you should find it's really pretty tricky. You've got to be very inventive with how you find your factorizations and how you find the values you need. Possible, but hard. This will make your life easier. I want to look at one more question just to see another situation where we can be a bit creative. So this question here, taken from a textbook where the worked example very much just gave the sort of Rietta's relations approach you'd see. But again, we should find a more creative way in here. We're looking for an equation with roots alpha beta, beta gamma, and gamma alpha. No obvious substitution. But if we say we can rewrite alpha beta as alpha beta gamma over gamma, so multiply numerator and denominator by gamma there, then at this point, again, we can note, we know the value of alpha beta gamma. Because alpha beta gamma is negative d over a, it's just going to be 3 over 3 or just 1. So this is just 1 over gamma, And similarly, this will be 1 over alpha, and this will be 1 over beta. So at this point, you're ready to make the substitution and say, well, we just want to let w equal 1 over x, rearrange. Again, it's not always the case where it just rearranges things the same way. It's just been a coincidence in these examples. We get to x equals 1 over w, replace x with 1 over w, and go through, and you're fine. The very similar sort of case, but worth watching out for because it's another common one that comes up. If you were asked to find an equation with roots 1 over alpha beta, 1 over beta gamma, and 1 over gamma alpha, you could do a similar thing where you rewrite this as gamma over alpha beta gamma, and again say, we know what our denominator is equal to now, and you straight away got a substitution you can make again. So look to see whether there's clever either multiplications or additions you can do to get it as a linear transformation of your alpha, beta, and gamma, and go back to using your substitution. This isn't going to work all the time, but if you find a case where it will make your life a lot easier, and there will be questions where 90-95% of the people doing the exam are really struggling, and you're just smashing through because you've spotted that way in. Right, thank you very much.